Hello. So we are continuing chapter 5 and the systems of linear equations. So 5.2, we're going to be looking at three variables. So systems of linear equations in three variables and their solutions. Any equation of the form ax plus by plus cz equals d, where a, b, c, and d are real numbers such that a, b, c are not all zero, is a linear equation in three variables. We're still looking at linear equations because the exponents are 1 for x, y, and z. Okay, a solution of a system of linear equations in three variables is an ordered triple of real numbers that satisfies all equations of the system. The solution set of the system is the set of all of its solutions. So the ordered triple looks like x, y, and z. Okay, next we're going to look at whether an ordered triple satisfies a system. So we have um, the ordered triple here, x, y, and z, and we need to figure out if it is a solution of this system right here. So we're going to start just like we did with two variables. Um, every single time we've got three variables, we should have three equations as well in order to actually solve for an ordered triple. We'll look at some that we might not have. But we need to use all three equations to make sure that this ordered triple is a solution of the system. So we're going to start with the um, first one, x minus 2y plus 3z equals 22. We're plugging in x as, or negative 1 as x, minus 2 times y, negative 4, plus 3 times 5 equals 22. So again, the left side should equal the right side. So negative 1 plus 8 plus 15. And when we do the addition, we get that 22 equals 22. So this is true. Okay, let's go on to equation number 2. 2x minus 3y minus z equals 5. Our x is negative 1 still, y is negative 4, and z is 5. So negative 2 plus 4 minus 5 equals 5. Hold on a second. I'm missing something here. That's not a 4. I'm missing a negative and a 3. That's what I was thinking. So plus 12. 12 minus 2 is 10, and minus 5 is 5. So again, this is true. Make sure that you do the calculations correct so that you get the true when you're supposed to. Okay, let's check the third one. 3x plus y minus 5z equals negative 32. And x is negative 1, y is 4, and z is 5. So negative 3, negative or minus 4 minus 25 equals negative 32. And yes, this is true as well. So the ordered triple negative 1, negative 4, 5 is a solution of the system. Okay, solving systems of linear equations in three variables by eliminating variables. So first we're going to reduce the system to two equations in two variables. And this is usually accomplished by taking two different pairs of equations and using the addition method to eliminate the same variable from both pairs. Step number 2 is solve the resulting system of two equations in two variables using addition or substitution. So what we learned in 5.1. The result is an equation in one variable that gives the value of that variable. Step number 3, we back substitute the value of the variable found in step 2 into either of the equations in two variables to find the value of the second variable. And step number 4, use the values of the two variables from steps 2 and 3 to find the value of the third variable by back substituting into one of the original equations. And then, of course, number 5, check, check, and check. Okay, so let's go ahead and look at our system in three variables here. So our first step is to reduce the system to two equations in two variables. When we're looking at this now, the easiest thing is to eliminate z. I mean, this is already telling us to do that, but looking at these, it would actually be the easiest because we have a minus z and a plus z here. So x plus 4y minus z equals 20, and 3x plus 2y plus z equals 8. So we're using 1 and 2. And we're going to go ahead and add x plus 3x is 4x, 4y plus 2y is 6y. Z's cancel each other out, and 20 plus 8 is 28. Okay, so we have now x and y. What we need to do is we need to get another set of equations and do the same thing so that we eliminate z from them. So we are going to have to use equation 3 because we didn't use it yet, but that's kind of a must for us to use in order to be able to, we can't use the same 1 and 2, of course. Now, what we are going to do is we can do either, or use either 1 or 2. I'm looking at this here, we have plus 2z. Easiest is if we take 1 and we multiply that by 2. So this was 3, this is 1 multiplied by 2. So 2x plus 8y minus 2z equals 40. So equation 1 multiplied by 2. And now we can add 2x plus 2x is 4x, minus 3y plus 8y is 5y. Z's cancel out, and then we get 24. Okay, now we have two new equations here. So we're going to say that this is number 4. Hold on, I'm trying to figure it out. Yeah, sorry. So equation 4, 4x plus 6y equals 28. And we're going to number this equation as 5. 4x plus 5y equals 24. Now, looking at these two equations here, we're going to keep this the same. So no change for the equation 4. 4x plus 6y equals 28. We are wanting to either use the addition or substitution. Now looking at equation 5, if we multiply this by negative 1, we get negative 4x minus 5y equals negative 24. Now if we add, the 4x's cancel each other out. we get y equals 4. Well, that was actually easier than, or very easy, because we get y straight. We don't have to um, do anything else. Um, everything cancels out. So now we have y. Now our next step is to use back substitution in one of the equations in two variables. That means, so the two variables, those are the equations 4 and 5. So we're just going to pick one of those equations, and I'm going to go ahead and pick 4, and we're going to rewrite 4x plus 6 times y, we're going to substitute with the 4 that we got, equals 28. So 4x plus 24 equals 28. 4x equals 4, x equals 1. So now we've got x and y. Next step is that we're going to back substitute the values found for two variables into one of the original equations. So we have x equals 1 and y equals 4. We're going to take one of the original equations here, and it really doesn't matter which one we do. I'm just going to pick the first one. So the first one is the x plus 4y minus z equals 20. And now we're plugging in x1 plus 4 times 4 minus z equals 20. Okay, so we get 17 minus z equals 20. We want to move the 17 to the other side. We get negative c equals negative 3. Divide by negative 1. We get z equals, hold on a second, something didn't go right. No, this should be a positive, equals 3. And z equals negative 3. So our ordered triple is 1, 4, and negative 3. And make sure that you check. And again, you need to go back and check all three equations that you've got. The order, plug the order triple in for every single one. Okay, now we're going to use what we just learned in an application. So find the quadratic function y equals ax squared plus bx plus c, whose graph passes through the points 1, 4, 2, 1, and 3, 4. We begin by substituting each ordered pair into the equation y equals ax squared plus bx plus c. So we're going to start with 1, 4. Our y is 4. Our x is 1. So 4 equals a plus b plus c. Okay, next we're going to do 2, 1. So our y is 1, a times 2 squared plus b times 2 plus c. Simplifying it, 1 equals 4a plus 2b plus c. And then 3, 4. Our y is 4, a times 3 squared plus b times 3 plus c. So 4 equals 9a plus 3b plus c. Okay, so we substituted each ordered pair into each equation. Now, to find a, b, and c, we will solve this system. So we've got 4 equals a plus b plus c. Our second one is 1 equals 4a plus 2b plus c. And we have 4 equals 9a plus 3b plus c. So we have first equation, second, and third equation. Okay, now we're going to start doing the same thing as we did step by step. So step one is reduce the system to two equations in two variables. This is already kind of giving us a hint what we're going to be doing. So we are eliminating c from equation 1 and 2. So our equation 1 is 4 equals a plus b plus c, and our equation 2 is 1 equals 4a plus 2b plus c. We're going to keep the first one like it is. Um, it really does not matter which one we are multiplying by -1. We can do that with either one of these. But -4a minus 2b minus c. You know what? I'm going to move this a little bit. Oops. So that I'm kind of aligned with the b and the c. So it really it doesn't matter which one we do first and which one we do second, or which one we multiply by -1. 4 minus 1 is 3. A minus 4a is -3a. B minus 2b is minus b, and the c's cancel each other out. So here's our equation number 4. Now, next eliminate c from equation 1 and 3. So our equation 1 is 4a equals a plus b plus c, and our equation 3 is 4 equals 9a plus 3b plus c. We're going to do the same thing. The top one is going to stay as it is. We're not touching it. And again, I'm going to try a plus b plus c. And this one multiply by -1. So -4 equals -9a minus 3b minus c. 4 minus 4 is 0. A minus 9a is -8a. B minus 3b is minus 2b, and the c's cancel each other out, and there is our equation number 5. Okay, step 2 is to solve the resulting system of equations in two variables. So our equation 4 is 3 equals -3a minus b, and our equation 5 is 0 equals -8a minus 2b. Okay, now we need to look at what do we want to do. Well, it looks like we have a -b here and a -2b here. So if we multiply the top, so equation number 4, by -2, we get -6 equals 6a plus a 2b. And then the fifth one is 0 equals -8a minus 2b. Okay, we're going to go ahead and add. So -6 plus 0 is -6. 6a minus 2 minus 8a is -2a, and the b's cancel each other out. We divide by -2, and we get a equals 3. So we got our first one. Now we're going to use back substitution in one of the equations in two variables to find the value of the second variable. We know that a equals 3. So we could take, for example, equation 4, 3 equals -3a minus b, and plug in a. So -3 times 3 minus b. So 3 equals -9 minus b. We add 9, so we get 12 equals negative b. We divide by -1 and flip it over, so we get b equals -12. Okay, we have a equals 3, and we have b equals -12. And now we need one of the original equations here. So one of these right here, I think we're going to pick the first one, 4 equals a plus b plus c. I feel like that one's the easiest because it doesn't have um, coefficients, or the coefficients are 1 for a, b, and c. So it's kind of the easiest to do the calculations. 4 equals a is 3 plus b is actually -12 plus c. Okay, so 4 equals -9 plus c, 13. Or I'm going to flip this over. C equals 13. Okay, we have all 3 right now. So we're going to go ahead and write our quadratic equation. Y equals 3x squared minus 12x plus 13 right here. Now, again, our step number 5, which is actually not mentioned here, would be to check. And again, what you need to do is we need to go all the way back to our original points here. 1, 4, 2, 1, and 3, 4. 1, 4, 2, 1, and 3, 4. And plug these points into our quadratic equation. So 4 equals 3 times 1 squared minus squared minus 12 times 1 plus 13. So xy. Okay, so 4 equals 3 minus 12 plus 13. 4 equals 4. This is true. And we do the same thing for each one. And since we get true, we know that that's the answer, or we got it correct. If one of them is false, then you would need to go back and check where it went, or even probably restart the problem. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.